The MiG-41, also known in some circles by its unofficial designation PAC-DP, Prospective Aviation Complex for Long-Range Interception, is Russia's ambitious next-generation interceptor aircraft currently under conceptual and preliminary design development by the Mikoyan Design Bureau. Intended as a successor to the legendary MiG-31 Foxhound, the MiG-41 is positioned to be the future of high-speed, high-altitude air defense for the Russian Federation. While much about the aircraft remains shrouded in secrecy, available data, speculative insights, and official statements provide enough material to envision the technical aspirations, strategic context, and the transformative role this aircraft could play in modern aerial warfare. At its core, the MiG-41 is designed to maintain Russia's capability to dominate the upper layers of its airspace and beyond, potentially even venturing into near-space environments. The MiG-31, with its speed of Mach 2.83 and unmatched ability to intercept high-altitude threats, set a standard that remains formidable even today. However, with growing challenges posed by hypersonic missiles, stealth bombers, space-based platforms, and the modernization of rival air forces, a newer, more advanced interceptor has become a strategic imperative. The MiG-41 aims to address those concerns, not only matching but surpassing its predecessor in every key domain: speed, range, altitude, sensor capabilities, and armament flexibility. Reports, although unverified, suggest that the MiG-41 could reach speeds in excess of Mach 4.3, with some speculative estimates even hinting at Mach 5 capability, effectively entering the realm of hypersonic flight. If achieved, this would position the MiG-41 as one of the fastest crewed aircraft ever developed, rivaling or surpassing historical platforms like the State Route 71 Blackbird. Operating at such extreme speeds and altitudes would allow the MiG-41 to intercept hypersonic missiles, spaceplanes, reconnaissance aircraft, and stealth bombers before they enter Russian airspace. The challenges associated with hypersonic flight, thermal stress, material fatigue, radar control, and propulsion, suggest that the aircraft would need to integrate advanced composites, cutting-edge engines, possibly scramjet or combined cycle, and innovative cooling systems. The aircraft is also expected to incorporate a degree of stealth technology, though it may prioritize speed and altitude over extreme radar invisibility, given its likely mission profile. Unlike multi-role fighters designed for air superiority or ground attack, the MiG-41 is an interceptor, and its mission centers around engaging threats at range as quickly and decisively as possible. That said, a low radar cross-section, internal weapons bays, and radar-absorbing materials are anticipated in the design. As a high-speed interceptor, it might also employ active electronic warfare suites and directed energy countermeasures to defeat enemy tracking and missile systems. In terms of range, the MiG-41 would almost certainly have an extended combat radius exceeding that of the MiG-31, perhaps pushing toward 1,500–2,000 kilometers without refueling. This extended reach is essential given the vast territory of Russia and the necessity to patrol its Arctic, eastern, and western borders. The ability to reach high altitude and project power quickly to remote airspaces aligns with Russia's strategic doctrine of layered air defense and deterrence. One of the most tantalizing aspects of the MiG-41 project is its rumored capability to operate in near-space environments. While that terminology may be vague, it hints at altitudes in the range of 30 to 45 kilometers or more, where most current aircraft cannot effectively operate. At those heights, the aircraft could potentially track and intercept space-based threats or hypersonic glide vehicles, providing a unique strategic niche between atmospheric flight and orbital defense. Such an aircraft would also require special life support systems, avionics capable of functioning in extremely thin atmospheres, and extraordinary sensor fidelity. Speaking of sensors, the MiG-41 is expected to be equipped with advanced radar systems, possibly next-generation phased array radars or quantum radar technologies. These would offer enhanced detection capabilities for stealth and hypersonic targets, even in contested electronic warfare environments. The onboard AI systems might provide autonomous threat tracking, target prioritization, and missile guidance optimization, allowing the pilot to function more as a systems manager than a direct operator. This would also open the door to unmanned or optionally manned versions in the future. The weapons systems onboard the MiG-41 will almost certainly include long-range air-to-air missiles, possibly improved versions of the R-37M or entirely new designs with extended range and high speed to match the aircraft's mission profile. Speculative discussions have also mentioned the use of laser weaponry or railguns in future iterations, though such systems remain in early development stages globally. Anti-satellite capabilities have also been hinted at by Russian officials, which would mark a new level of air defense escalation and military space capability. Another aspect worth considering is the aircraft's integration within the larger Russian defense ecosystem. The MiG-41 is not being designed in isolation. It is envisioned as a key component of Russia's layered integrated air defense system (IADS), which includes surface-to-air missiles, radar systems, electronic warfare platforms, and existing aircraft like the Su-57 and MiG-35. The MiG-41, therefore, would operate in coordination with these systems, feeding data to and from airborne early warning and control aircraft, satellites, and ground command infrastructure. Mikoyan has made sporadic official statements confirming the existence of the POC-DP program and expressing intentions to field the aircraft sometime between the late 2020s and early 2030s. However, no prototype has been seen, and no official mock-ups have been unveiled publicly. Russia's economic constraints, technological challenges, and the high cost of developing a platform of this sophistication raise valid concerns about whether the MiG-41 will materialize in its most ambitious form or be scaled back. Still, Russia has surprised the world in the past with its ability to field advanced aerospace systems under challenging conditions. There is also the question of how the MiG-41 will influence or challenge Western air defense and aerospace strategies. The United States, for instance, is developing its own next-generation air dominance (NGAD) fighter, while Europe is moving forward with the Tempest and FCAS programs. However, none of these platforms are specifically interceptors designed for hypersonic threats at high altitude, giving the MiG-41 a unique strategic role. If fielded successfully, it could force NATO and other potential adversaries to rethink the survivability of their high-speed platforms and reconsider their assumptions about airspace invulnerability. It's also important to view the MiG-41 in the context of Russia's growing interest in hypersonic weapons, such as the Kinjal and Zircon missiles, and the broader militarization of the high-altitude domain. The MiG-41 might not only be a defensive asset but a platform capable of offensive hypersonic strike. Some analysts have even speculated about the aircraft being able to launch small satellites or counter-satellite weapons, further blurring the line between air and space combat capabilities. From a design standpoint, concept art and speculative renders depict the MiG-41 as a sleek, sharp-angled machine with a twin-engine configuration, flush-mounted intakes, and an overall stealthy appearance. Some designs show blended wing bodies, minimal vertical stabilizers, and aggressive forward swept lines. While it's unclear how much of this reflects reality, it's likely that the aircraft will adopt a balance between speed, stealth, and sensor integration. The design will be dictated heavily by the demands of hypersonic flight, meaning heat management, aerodynamic stability, and minimal drag will be as crucial as radar cross-section. One major technical hurdle is the propulsion system. For Mach 4 plus flight, traditional turbofan engines are insufficient. The MiG-41 might use variable cycle engines, ramjet-scramjet hybrids, or an entirely new propulsion system being developed under top-secret programs. Such engines would need to function across a vast envelope of speeds and altitudes, from takeoff at subsonic speeds to cruise at hypersonic velocity in the upper atmosphere. The engineering complexity involved is massive, which explains the long timeline and secretive nature of the project. The cockpit, though speculative, would likely be a fusion of high-end avionics, augmented reality displays, helmet-mounted sighting systems, and AI-driven data integration. Whether single-seat or two-seat configurations are chosen remains unknown, but it's probable that the aircraft would lean toward maximum automation and minimal crew workload. Given Russia's recent experiments with unmanned aerial combat systems, there's also the potential that future versions of the MiG-41 could be autonomous or remotely piloted for high-risk missions. Despite the excitement and potential, skeptics question whether the MiG-41 is more propaganda than progress. Russia has a history of announcing futuristic projects that either get delayed or scaled down due to economic limitations or shifting military priorities. However, the need for a MiG-31 successor is real, and the technological race in hypersonic and space-adjacent domains is heating up. Even a partial realization of the MiG-41's goals would represent a major leap forward in interceptor capabilities. In summary, the MiG-41 stands at the intersection of aspiration and necessity. If brought to life as envisioned, it could redefine the limits of crewed flight and create a new category of aerospace dominance. A Mach 4 plus near-space interceptor capable of defending against stealth aircraft, hypersonic missiles, and possibly orbital threats would be an unprecedented force multiplier. Whether it becomes a reality in its full form or ends up as a more modest evolutionary step, the MiG-41 is already reshaping how we think about the future of air defense and high-speed aerial warfare.